Hello and welcome to 2003 Physics. Let's go through the multiple choice. Alright, question 1. The weight of an astronaut on the moon is 1/6 of her weight on Earth. What is the acceleration due to gravity on the moon? Assuming that her mass stays the same, which in this case, yes, it does, the only thing that can change is acceleration, right? So it can't be C, and it would change linearly, so it has to be B. 9.8 divided by 6. Alright, that's too simple. 2. A satellite moves in uniform circular motion around the Earth. The following table shows the symbols used in diagrams below. Okay, which diagram shows the direction of F and V at the position indicated? Okay, so it's A, and let's go about why it's A. So we can just use the process of elimination. It can't be B, because if the force was acting outwards, then this would go out of orbit. It can't be C, because it would just crash back to Earth. And for the same reason as B, it can't also be D, because then this would escape, given enough velocity. So it has to be A. And it would, its velocity will always be tangential to the circular path. For a satellite moving in uniform circular motion around Earth, the centripetal force is provided by the gravitational force. Okay. Which of the following equations should be used to calculate the speed of the satellite? Alright, so this is just orbit speed. Fairly simple, and this is just a memorized question. Do you remember this? The answer is B. Okay, so two planets X and Y travel around the star in the same direction. In circular orbits, planet X completes one revolution in time t. So planet X is the small one. The radii of the orbits are in the ratio of 1 to 4. How many revolutions does planet Y make about the star in the same time t? So, since the speeds are different, this planet Y can't rotate faster than planet X, because remember the Kepler's laws, r cubed over t squared. So for that reason, it can't be 2 or 8. So let's just apply Kepler's law straight away. So 4 times 4 times 4, and square root is 8. So planet Y will do 1/8 of a revolution. Okay, onward to question 5. An astronaut set out on a spaceship. Okay, the spaceship traveled at 0.8% the speed of light. The journey took 10 years. A clock remained on Earth. What time and years had elapsed on this clock when seen from the astronaut's spaceship? So in this case, is looking to a different frame of reference. So time dilation would be shown here. And the equation for time dilation, it's on the data sheet, but it's 0.8% the speed of light divided by the speed of light squared. So just 0.8 squared. And then 1 minus 0.64, which is the answer that we got before. And we take the square root of this, 0.6 times 10 years. And we get 6 years would have passed on Earth. The diagram shows a DC generator connected to a cathode ray oscilloscope. So DC means direct current, it's always acting in one direction. So by default, C and D can't be correct because the direction is switching from positive to negative. And for A, it shows constant voltage, but that's not what's happening here. We only see two sets of bars magnets. So the voltage would change over time as the motor, or as the generator revolves. So the answer would be B. Okay, question 7. A non-magnetic metal disc is balanced on a support beam as shown in the diagram below. The disc is initially stationary, and the magnet is moved in the circular path just above the surface of the disc without touching it. So the disc will begin to move. And why does it move? Because of Lenz's law. And remember that Lenz's law, whenever there's a change in magnetic field in a conductor, the conductor will produce a back EMF that opposes the change. So in this case, the disc moves with the magnet because it wants the relative motion between the disc and the magnet to be 0. So Lenz's law is what we're looking for here. Alright, so do we find Lenz's law in the DC motor? Well, sometimes, but we mostly find back EMF. Actually, no, we find the right-hand slap rule, actually. A galvanometer? Nope. A generator? Yeah, but it's mostly for back EMF. And an induction motor? Yes. We see Lenz's law used in induction motors. Okay, so a neon sign requires 600 volts to supply for its operation. A transformer allows a neon sign to operate from 240 volts supply. What is the ratio of the number of secondary turns to the number of primary turns in the transformer? So since 240 volts is being stepped up to 600 volts, there needs to be more secondary turns than primary turns. So it can't be B or A. We can rule those out. So now to figure out the amount of turns, we need to do 6,000 divided by 240. 6,000 divided by 240 is 25. So the answer would be C. For every 25 secondary turns, there will be one primary turn in the transformer. Okay, question 9. A current of 5 amps flows in a wire placed in a magnetic field 0.5 teslas. That is 0.57 meters long at an angle of 60 degrees to the field. What is the approximate magnitude of the force on the wire? So since it's at an angle, we need to calculate the perpendicular length of this wire to the magnetic field. So 0.7, actually 60 sine times 0.7 meters. So this is the perpendicular length acting on the magnetic field times current times magnetic field, and we get 1.5, and that is our answer here. So that's the magnitude of the force. C. Okay, question 10. A flexible wire loop is lying on a frictionless table made from an insulating material. The flies can slide around horizontally and is free to change shape, but cannot move vertically. The loop is connected to a power supply, a switch, and 2 terminals fixed to the table below. When the switch is closed, a current I flows through the loop. Which of the following diagrams most closely represents the final shape of the loop after the switch is closed? Okay, so it can't be D, because opposite wires traveling in opposite directions will repel each other straight away. We can do this just by the right-hand grip rule, and I'll leave that for you to find out. It's for the same reason, it can't be B, because you can see parts of it is traveling in opposite directions, and that would cause it to repel afterwards. And again, for the same reason, it can't be C, because even though it doesn't look like it, there are parts in here where they are traveling in opposite directions, and even though that they aren't as close as B and D, they are still going to repel each other. Okay, so what about A? Well, A doesn't look like there anything traveling. There are no wires traveling apart. Like, you can say one side of a circle and this side of the circle, they're traveling apart, right? But that's when the distance is maximized, so the force is limited here, and thus the wire would be seen stable. While in these ones, the wire would just flip right out. In fact, all these, in fact, B, D, and C will eventually collapse to A, given that the table is frictionless. So the answer there is A. Okay. Question 11. Which of the following did Braggs investigate using X-ray diffraction? Alright, this is just a memory test. Cathode rays? Nope. Crystal structure? Yes. And C and D? Nope. Cathode rays was done by a lot of people. 12. In a first-hand investigation that you have performed, you have used a discharge tube containing a Maltese cross. You would have observed an image similar to the one shown below. Which of the following statements is a valid conclusion from the observations made in the Maltese cross investigation? Cathode rays pass through glass? Nope. Cathode rays pass through metals? Well, if the Maltese cross was made out of metal, then this would be invalid. cathode rays are charged particles. It doesn't tell us anything about that. But D, cathode rays travel in straight lines. Yeah, that's correct. And in fact, the Maltese cross was an argument that cathode rays was EMR, when in fact it was actually charged particles. Alright, 13. An N-type conductor is produced when silicon is doped with small quantities of phosphorus. How will this doping change the crystal's electrical conductivity? The conductivity will decrease because there are fewer holes in the valence band. Well, that's not true. N-type means it has an extra electron in the conduction band. If we remember back to ideas to implementation, and that's what D says here. More electrons in the conduction band. So D. Alright, 14. Heinrich Hertz used a setup similar to the one shown below to investigate the production and detection of electromagnetic radiation. Which of the following observations is consistent with the photoelectric effect that Hertz produced? Radio waves are blocked when the glass sheet was in place. Well, that's not true. Radio waves are always traveling through us. You can use the radio in your room, and the radio would pass through the walls. Ultraviolet waves were blocked when the glass sheet. Well, that's not true. This machine did not produce ultraviolet waves. The maximum spark was longer when the glass sheet was in place. This doesn't make sense because it implies that somehow those the photoelectric effect, the electrons gained more energy to jump the gap. That doesn't make sense. But the maximum spark length was shorter. That makes sense because the radio waves had to penetrate the glass, so it would have lost some energy in that process. Okay, last one, 15. A positively charged particle, charged ion actually, traveling at 250 meters per second, is fired between two parallel charged plates M and N. There is also a magnetic field present in the region between the two plates. The direction of the magnetic field is shown into the page as shown. The ion is traveling perpendicular to both the electric and the magnetic fields. The electric field is between the plates is 200 volts per meter. The magnetic field is adjusted so that the ion passes through undeflected. What is the magnitude of the adjusted magnetic field and the polarity of M terminal relative to N terminal? Okay, this was quite a lot. Let's go through this slowly. Okay, so let's apply the left-hand rule to find out which way the magnetic field deflects the particle. So since it's a positively charged particle, our thumb has to point in the opposite direction, our fingers point into the page, and our palm points up. So that means M has to be positive to repel it back down, so it can travel in a straight line. So we can rule B and D out. Now how do we figure out the magnitude? Well, recall that F is equal to charge times the potential difference between the plates, and that's for an electric field, and F is equal to Q V B. This is for a magnetic field. So we can equate them. We get Q V B, where V its velocity is equal to Q E. The Q's cancel out, and we get B is equal to E over its speed, velocity. So let's do that. So its electric field strength is 200, and divide by 250, and we get 0.8 teslas. And alright, that's the end of multiple choice. Alright, thank you.